Hi everyone, my name is Burak Yıldız. I'm a researcher at Computer Vision Lab at Delft University of Technology. I will present our paper titled Reproducedpapers.org, Openly Teaching and Structuring Machine Learning Reproducibility. Let's start with reproducibility. Reproducibility is to do the similar work in the described way and to try to get similar results. Reproducibility is very important for scientific workflow. However, works in machine learning lack reproducibility. Possible reasons may include a misaligned incentive between reproducing results and short-term users. There are venues for publishing reproductions. Some of them are peer-reviewed. They have quality standards. We argue that this quality requirement is hurdle for sharing lightweight reproductions. There are also low barrier options, such as reproducibility challenges. However, such venues may or may not be organized regularly. We argue that there is a need for a low barrier and long-term venue for machine learning reproduction. A complementary angle for low barrier reproduction is teaching ML. We can teach the importance of reproducibility, and we should do that, at the same time doing reproducibility works. We can do it with a reproduction project in an ML course. It aligns with several objectives, and 4 of them are reading a paper, implementing the method in the described way, running experiments, and writing a report. So, what we did in this paper? First, we conduct a proof of concept reproduction project in the machine learning course in our university. In addition, we developed an online reproduction repository called Reproducedpapers.org. Lastly, we evaluated the usefulness of this repository. Let's dig into the details of the reproduction project a bit. We collected a bunch of papers to offer students to reproduce. We ensured that the data is available, the reproduction target is clear, and the computation power is reasonable. Students worked in a group of 2 to 4 members for about 8 weeks. At the end of the project, they needed to supply a blog post that describes their work and a poster presentation. Students are explicitly allowed lightweight reproductions, for example, evaluating existing code, checking only certain parts of the paper, proposing minor variations, doing hyperparameter sweeps, etc. We have a quick demo of Reproducedpapers.org. This is it. It is developed by us from scratch, and it is open source. It accepts any sort of reproductions. Currently, there are 57 reproductions for 24 papers. On the home page, we can find a list of reproductions. Here is a menu button for the list of reproduced papers. Users can directly search a paper or reproductions here. For example, let's search CMS network. Here is the detail of the paper. Users can add to compare their results. Users can add tables to compare their results with the original results. Here. This gives other users a quick comparison chance. Below, we can find all reproductions that belong to this paper. Here we can see the details of the reproduction. With this code button, we can access the source code of the reproduction. With this detail button, we can go to the more detailed blog post for this reproduction. Let's move on to the presentation. When we look at the success rate of the reproductions in the website, it is about 40%. Some of the paper have high success rates and some of them have low. Lastly, we evaluated the usefulness of the repository with 2 anonymous surveys. One of them is for students and the other is for AI researchers. We got total 144 responses. Let's have a look at the results briefly. Students say that doing a reproduction increases critical thinking. They also say doing a reproduction makes them value reproductions more. They gained positive experience from the project. Almost everyone says that reproduction is valuable. This is from the both surveys. Again, almost everyone says that an online repository for reproduction is valuable. Lastly, again, almost everyone says doing a reproduction is educational. As a result, reproduction project aligns well with learning objectives. Reproduction project improves the perceived value of reproductions. Finally, AI researchers are positive about an online reproduction repository. Thank you for listening.